Okay, so our learning target in to start off this unit is translations. And what you should see on the diagram is that triangle ABC. So if I pick a point on triangle ABC, the blue triangle, they've all the points have moved. That looks like left 5 and down 3. Okay. And the same thing happens with A. A to what we call A prime, the A apostrophe. That's left 5, down 3. If I look at point C to C prime or C apostrophe, that's left 5, down 3. So somewhat similar to slope, what that equation is yelling at us, or that rule, is the movement of any given point onto its translated point, which is the translation is ultimately a slide up or down, left or right on the coordinate plane, and moving that -5, that's telling us we're moving left 5. That -3 is telling us we're moving down 3. So the rule is telling us to get the pre-image. I'll put that on here for you. The pre-image so our image we're starting with, triangle ABC is the pre-image. And the triangle with the apostrophes, triangle A prime, B prime, C prime, is what we call the image. And the rule that tells us how to move that, how to move one onto the other, how to translate one onto the other is x minus 5, which means left 5, and y minus 3, which means down 3. Okay, so with that done, sorry about that. So now I'd ask, what would the rule be to move triangle ABC 2 units right and 1 unit up? So first, let's graph what that looks like. Got a little graph paper. Pause it real quick and graph that. So right 2 units, up 1. That is going to be the location, and we're going to call this B double prime, B double apostrophe. A moves right 2, up 1. A double prime is going to end up there. C, right 2, up 1. C double prime, going to end up right there. We still have the exact same triangle. That's another property of a translation. The triangle hasn't changed size. It's moved up 2 and right 1. So our rule, what happened to all the x's and y's? If I pick any xy, what's going to have to happen to it? Well, A went from, that's 0, 3. 0, 3 right there. And that's moved up to right 1. It's now at 2, 4. So very clearly the x increased by 2. That's the first part of the rule. And the y went from 3 to 4, which is an increase of 1. So turning those words into a quick algebraic rule is simply, all right, right is positive movement on the graph. Up is positive movement on the graph. So that takes us to part C. Let's generalize this a little bit. So I think the first part, H, think horizontal. And K, think vertical, and misspell it. I missed the T. There we go. Vertical. Okay, there's a K sound in vertical, especially if you misspell it. It's normally spelled with the C. So H is telling us how to move horizontally. K is telling us how to move vertically. So any translation rule can get modeled by simply writing, all right, whatever x, y we're at, the rule that translates it is going to be x plus or minus h. and y plus or minus k. And that's something that's going to keep popping up throughout math, not just here in geometry, but throughout your math. All right. Next part, are the sides of both triangles the same? So let's just look back at the original red and blue triangles, the pre-image ABC and the image A prime, B prime, C prime. And are they the same? And just kind of some quick distance formula confirmations. All right. That's 2, that's 4. That's 2, that's 4. So yeah, they're both the same. AB is going to equal A prime, B prime, and they're both going to equal. So quick little, sorry about that, quick little review from unit 1. Distance formula, we have the x change is 4, the y change is 2. We grab our calculators, that's 16, that's 4. Both of those are square root of 20. If we look at A to C, that's a drop of 6 and a run of 3. Drop of 6, run of 3. So both of those are the same. And that's a property of translations. Translations will not change the shape size. It's just going to change where it's located. So we got technically a 3 squared and a 6 squared. Calculator or mental math. 3 squared is 9. 6 squared is 36. 9 plus 36, it's square root of 45. So right here and right here. And we're almost done looking at all the side lengths. So is BC the same on both? And we should see, all right, B's up there at 6. The drop down to -3 is 9 and 1. Do we get the same thing for B prime, C prime? My bad, that's 5. That's 5. So that's a drop of 8, run of 1, run of 1, rise of 8. Bottom line, we got an x change of 1, a y change of 8. So we've got root of 8 squared. Again, I got that technically backwards. 1 squared plus 8 squared. We grab our calculator or do the mental math. That's 1. 8 squared is 64, so it's root 65. So yeah, the side lengths of both triangles are the same. They are, another word that we'll be talking about a lot to finish up the semester is congruent, meaning they are identical, okay? And last part, are both triangles right triangles? Oh, the first way is quick Pythagorean theorem. If a right angle exists, it's right there. So if I take the AB and the AC and throw them in Pythagorean theorem, 20 squared plus root 20 squared and root 45 squared, does that equal the root of 65 squared? Sorry, I held down on the mouse a little too long there. If you grab your calculator, type all that in, you'll get 65. A square cancels a square root, something we've been talking about a little bit here and there. So we got 20 plus 45 after the square cancels the square root. We got 65 on the other side. So according to Pythagorean theorem, we got a right triangle. The other thing that is, so that's a review from 8th grade. Do Pythagorean theorem to see if you got a right angle or not. It's right, so it's a right triangle. The other method, and we've already talked about this, what is the slope of AB? Well, it's rise of 2, run of 4, simplifies to 1/2. What is the slope of AC? Let's, we've already talked about it. We got a drop of 6, a run of 3. We divide that and simplify it. We got -2 over 1. Hey, negative reciprocals. It's perpendicular, which means we've got, again, a right triangle. Please take this and do your best to get started with translations. Again, the new learning target, the focus on A, B, and C is that you will add or subtract some number to the x. Positive is movement to the right, negative is movement to the left. And you'll add or subtract something to the y. When you're adding or making it positive, you are moving it to the right. And when you are subtracting / making it negative, you are moving it to the left.